Reno is not tectonically stable. The San Andreas Fault is a famous big fault in California that many people call the boundary between the Pacific plate and the North America plate. But in reality, the motion between those two plates actually extends all the way inward into Nevada and all the way to Utah. So anywhere between Utah and California, the crust actually is straining as a result of the tectonic plates moving. My name is Corné Kramer. I'm a professor at UNR. I have a joint position at the Nevada Bureau of Mines and Geology and the Nevada Seismological Laboratory. My research area is plate tectonics and crustal deformation, mostly using GPS data. Here we are with a GPS monument. This particular monument is installed by the National Science Foundation about 18 years ago. Its name is P090. This monument is drilled for 30 feet into the ground, so it's very stable. And this is an antenna here. In here, we record signals coming from GPS satellites to a millimeter precision. And if we compare how one station moves relative to the other station, it tells us about how much the crust between these two stations is straining. And that straining tells us something about the potential for there are going to be earthquakes in the future. There's a cable that goes from the antenna to this box here. In this box, there's a couple of batteries for power, which is powered by the solar panel over here. And then inside there's an expensive piece of equipment that collects the GPS data and then pushes it onward to the internet for people to use. And then I, in my research, use that information to build these maps of how the crust is deforming all across the western United States. There's a sticker here, and all those dots, there's a station all the way from the Caribbean to Alaska that's operated by the National Science Foundation. Now, there is another department here at UNR campus. It's in the engineering college. That's responsible for testing what kind of design of building and bridges can withstand what type of shaking that would happen during an earthquake. Meanwhile, the people in the seismological laboratory, they record all the tiny little earthquakes that happen all the time. And it's important to record those because ultimately the big earthquakes in the future are likely going to be in the same places where the small earthquakes are happening today. So this is very important research for seismic hazard analysis. It allows us to give probabilities about how many and how big earthquakes you might expect within the next 50 years in a particular area.
Primarily, a lot of the crustal motion is coming up through the San Andreas Fault, and then that transfers up into Nevada through what's called the Walker Lane, which runs up basically through Death Valley on the eastern side of the Sierras. And then essentially every mountain range you're seeing in Nevada is formed from what's called extensional tectonics. So basically the earth is spreading apart in Nevada and creating these mountain ranges and valleys that you'd see driving through the state. I'm William Savrin. I'm the network manager of the Nevada Seismology Lab. We run a large-scale microwave network around the state that's used for regional seismic monitoring, and we also have a network of fire cameras that are used to detect wildfires around the state. So when I was really young, I was down in California for the Northridge earthquake, which was a pretty large and devastating earthquake that happened in 1994. I wasn't that close to the earthquake, thankfully, but I did feel it, and I think that kind of sparked my interest in earth sciences. So this is an example seismometer called a Raspberry Shake. It's based off a Raspberry Pi, and they're relatively cheap. Anyone could buy one. So you can see when I jump right here, you'll see the ground motions start to show up on the monitor right here. And so this is essentially what we have out in the field all over the state monitoring earthquakes. So we don't do any predictions, and it's actually impossible to predict earthquakes at this point in time. So we're strictly just listening for seismic waves traveling through the earth. So we're providing data, earthquake data to scientists through the U.S. Geological Survey for scientific research, but we're also providing locations of earthquakes to the public. That's the really cool thing about our lab is we have a really nice crossover between the science you know, in the public safety, public service mission, because all of the products that we create and send out and display are all available to the public.